So good morning guys and welcome to my vlog, and guys, today we need to make a video presentation about strong acid and bases in our chemistry. And the main idea in this topic is the strong acid and the bases ionize completely in a solution. Our essential question: why should we study the strength of acid and bases? So I had to take a bath first before I make the video presentation. So let's take a bath. Come on! And now guys, I've already take a bath and bibihis na ako. And after that, we will find Sanpai Dum-Dum. Yun lang. So what's up guys? Now we're looking for Dum-Dum and hindi ko alam kung nasaan siya. Alam nyo ba kung nasaan siya, pre? Alam nyo? So let's find him.
A few moments later.
Oh, there he is. See? Oh, Dum-Dum, how are you?
I'm fine, bro. I'm taking a coffee. Oh, how was it?
Oh, of course.
There's a coffee too.
Oh, yeah. I like this one. Yummy. So, Dum-Dum, let's talk about strong acid and bases.
But wait, did you know that coffee is naturally acid because it contains chlorogenic acids such as chloric, caustic, and humaric acids? So what's with the strong acids and bases though?
Did you know guys, strong acids and bases ionize almost completely, while weak acid and bases do so partially. So Dum-Dum, what's next?
So before that, let me change my clothes.
Wow!
Now, let's talk about that. This follows that the ionization constant of strong acids and bases are relatively larger than those weak acids and bases. Take note that the stronger the acids, the weaker its conjugate base, and the stronger the base, the weaker it conjugates acid. So, for a further explanation about the strength of acids and base, well, let's change our place.
Whoa! Oh, it looks
Wait, bro,
amazing.
something is missing,
Oh, hey
bro.
Dum-Dum,
Bro, something's missing.
is there a classification for acid?
Yes, there is, but
Oh.
where's my coffee? Where's my coffee? Where's my
Oh,
coffee?
you mean binary and ternary? In which binary
Where's
acids
my
are
coffee?
hydrogen compounds of the
Where's my coffee,
halogens,
bro?
or let's say from group 7A elements. Hey,
And to add, their strength depends on the bonding between the energy of hydrogen and the halide. And among the binary acids, the hydrofluoric acids are considered the weakest, and the rest are strong acids. And with hydroiodic acids, it's the strongest among them all. Have you seen my
oh
coffee, bro?
yes, you're right.
Where's my coffee?
And in terms of ternary acids, guys, it has an acidic hydrogen bonded to an oxygen atom.
And guys, this binary and ternary acids, ternary are more likely referred to be oxoacids or oxyacids. They are maybe furthermore be classified as monoprotic, diprotic, and polyprotic depending on the numbers of protons an acid molecule can donate. But where's my copy, bro?
And for further information, okay guys, let's go somewhere else that will help us more information about ternary acids.
Bro, I didn't find my copy. But guys, the relative strength of the ternary acids are influenced by several factors. Let's go.
So, let's go!
Hey!
Hey! What's up?
So welcome guys, nandito kami ngayon sa aming laboratory classroom. This is just Thomas classroom, so that is
Yeah.
about here. So this is a whiteboard marker, and so okay guys, here we are, and we're going to discuss about what are the factors that influence the relative strength of ternary acids. First, we have oxidation state of the central atom. For oxyacids that have the same central atom, the one whose central atom has a higher oxidation state is stronger. So I'll give you some examples. In this case, it is obviously seen that the central atom is SO, which is sulfuric and oxygen, and therefore that this central atom is higher than the other one. Therefore, this is much more stronger acid than the other compounds. Get it? So let's proceed to the other factors. What influence the relative strength of acids? Let's talk about the second part of factors that influence the relative strength of ternary acid. We have electronegativity of the central atom. For the oxyacid with different central atom but similar oxidation states, the one with the more electronegative central atom is stronger. So I'll give you some examples that consider the difference, such as with chlorine, bromine, and iodine as their central atom. So now, for our example, we have chlorine, bromine, and iodine as their central atom. Even though they have the same electronegativity with hydrogen and oxygen, but they will differ from their central atom, which is chlorine, bromine, and iodine. So now let's talk about for the third part of our factors that influence the relative strength of ternary acids. For the last part of our ternary that influence the relative strength, we're going to talk about the electronegativity of an atom attached to the central atom. So for oxyacids with the same central atom and the oxidation states, the electronegativity of an atom attached to the central atom affects the strength of the acids. A more electronegative atom increases the strength of the acids. A less electronegative atom decreases its strength. For the acids below, the central of the atom, sulfur S, is attached to fluorine and oxygen and another sulfur atom. Because guys, sulfuric acid, which is HSO3F, is the strongest acid because it has the most electronegative atom, fluorine. And also thiosulfuric acid, which is S2S2O3, is the weakest acid because it contains the least electronegative atom, sulfur, that attach to the central sulfur atom. So that's all, guys, and we're going to talk about the next topic, which is the pH of strong acids and base. See you guys.
We're going to do a series of titrations to generate titration curves for strong acid with strong base, weak acid with strong base, and weak base with strong acid. The first titration will be a 0.1 molar solution of HCl with a 0.2 molar solution of sodium hydroxide. We're going to pipette 50.00 milliliters of an approximately 0.1 molar solution of HCl into the beaker. We're going to add 2 to 3 drops of bromethymol blue indicator. Bromethymol blue is yellow in acidic solution and blue in basic solution. It changes color at about a pH of 7. We'll place a calibrated pH electrode into the solution. We're going to collect data using trigger prompt. We've already calibrated the pH electrode, so we're going to come down to collect data and trigger prompt. We're going to wait 30 seconds for the electronics to warm up. That's enter. We're going to add the sodium hydroxide solution in increments, and we're going to press trigger after the CBL reading has stabilized each time and enter the volume from the burette. The first reading will be at 0 milliliters of NaOH. So we're going to take a reading before we've added any NaOH. When the CBL reading is stable, we'll press trigger on the CBL and we'll enter the volume on the calculator. 0.00 milliliters. It'll ask us to collect more data. We want to collect more data. We're going to carefully add 2 milliliters of NaOH solution. If you don't reach 2 milliliters exactly, what you want to do is just read the volume carefully off the burette and enter it to the nearest hundredth of a milliliter. When the CBL reading is stable, press trigger on the CBL and enter the volume on the calculator, in this case 2.00. Again, collect more data. You'll collect data every 2 milliliters up to 20 milliliters, every 1 milliliter from 20 milliliters to 30 milliliters, and every 5 milliliters from 30 milliliters to 50 milliliters. You also want to try and record the volume where the indicator changes from yellow to blue. When you've reached 50 milliliters, press trigger, enter the value on the CBL. You'll do a stop and graph and save your data to a program. This is the graph of the titration of the HCl with NaOH.
So what's up sa inyo guys, and now nagbabalik kami upang para sa aming reflection.
in our
And
strong
you know
acid
guys,
and bases.
strong acid and bases, just like that, they ionize the almost completely, and just like us, just like tao, na ganito sa mga ginagawa natin na kahit anong bagay pa yan na mabuti o masama, yun yung magiging yun yung sinabi ni Dambo. At yun lang mga kaibigan. Dambo, ito ang sabi mo.
I just wanted to say guys that just like strong acids, the stronger the acids, the weaker it conjugates base. And the stronger the base, the weaker it conjugates acid. So sa atin, the more na mas pinipili nating mapabuti, maging parte ng Panginoon, the more na lumalayo tayo sa masama. At the more na mas kung pipiliin naman nating mapasama, the more na mas layo tayo sa mabuti. Kaya guys, nasa atin yun if we want to be an acid or base, if we want to be good and evil. So guys, Cheyan.
So yun na nga mga kaibigan.
I am your Sensei Damdam.
And your Sensei JM. Dito na namin tatapusin ang aming vlog. And yun ang masasabi namin.
Umiinit na preso. Magbabay na tayo.
Bye-bye!
Bye-bye!